In this video, equipment configuration and testing procedures are demonstrated. Before starting the one-dimensional consolidation test, you will need to configure the digital readout, the loading frame, the LVDT, and the data recording software. On the digital readout, you will see 4 digital channels labeled LD1, DSP1, LD2, and DSP2, which stand for Load Cell 1, Displacement 1, Load Cell 2, and Displacement 2 respectively. You will first need to determine which channels correspond to your sensors. To do this, manually move the needle of your LVDT while observing the digital readout. The displacement channel corresponding to your LVDT will change. In this setup, we have our LVDT connected to DSP2. Hence, our load channel is LD2. While the load cell is not in contact with the ball, the load cell reading should be 0. If the digital readout is not 0, we should tear the load cell channel. To do this, first press the tear button and then select your load cell channel. The load cell channel is now showing 0 kilonewtons. Next, you will need to lower the loading frame so that the load cell is almost touching the ball. The loading beam is supported on 2 hex nuts. Adjust these hex nuts simultaneously to lower the beam while keeping it approximately horizontal. In this way, lower the beam until the load cell is sufficiently close to the ball. Tighten the wing nut to secure the loading beam in place. Next, you will need to configure the LVDT. Note that the LVDT is attached to a fixed position on the apparatus using a mounting bracket. This bracket can be loosened using the wing nut so that the position of the LVDT can be adjusted. The needle of the LVDT needs to be in contact with the loading beam that will move downwards as the specimen settles. Hence, adjust the LVDT so that the needle is touching the loading frame. Make sure that the needle has sufficient range for downward movement. Now you will need to bring the load cell into contact with the specimen. To do this, first release the pressure using the regulator. Then, set the loading value to the load position. Now, turn the pressure regulator in the clockwise direction slowly while observing the load cell readout. Stop when you see a load on the readout. This is your seating load. It is preferable to have a seating load that is less than 10 newtons. Do not worry if you overshoot this number. Record the load cell reading as your seating load. Now, press on the tear button and select your displacement channel. Next, flood the specimen by filling up the reservoir with water using the provided bottle. The specimen must remain flooded with water for the whole duration of the test. You will need to check this daily and top up the water level when needed. Now the data recording software can be configured. Double-click on the icon Get Data _412. Click on Acquire New Data. Change the time interval to 5 seconds. Now click on Start Time to Test to start data acquisition. At this point, you are ready to apply the first load increment. The load increment is applied by rotating the pressure regulator in the clockwise direction. From the Get Data Acquisition window in the software, you will see that load data increases to the target load and LVDT data shows the settlement of the specimen.